have discussed about physical properties of aldehydes and ketones and the mechanism of nucleophilic addition reactions. And there we have also learned that aldehydes are readily undergoing the nucleophilic addition reactions than the ketones and the reasons for that. In the present class, we shall consider some examples for nucleophilic addition reaction. The first one is addition of hydrogen cyanide. Addition of hydrogen cyanide to the carbonyl compounds. It may be aldehyde or ketone. Okay. Addition of hydrogen cyanide. See here, hydrogen cyanide, where there will be two parts, H plus, that is positive part, and cyanide part is negative part. Here, the negative cyanide part will attack on the carbonyl carbon. Okay, let us see that. HCl we have. Here, we are going to take the alkaline HCl, means HCl is added to the NaOH, for example. Okay. And it gives the NaCl plus H2. We are adding HCl to the NaOH to get NaCl. Okay. Now this NaCl will be added to the carbonyl compound like this. Take the carbonyl compound. It may be aldehyde or ketone. Okay. What is this? It is a carbonyl compound. It is a carbonyl compound. Maybe aldehyde or ketone. Maybe aldehyde or ketone. To this we are going to add the cyanide. See, even though if you add NaCl, first the cyanide will attack. The cyanide will attack onto the carbonyl carbon. It will attack onto the carbonyl carbon because this is delta plus, this is delta minus. The carbonyl compound is a polar molecule where the carbonyl carbon is having a partial positive charge. The oxygen will have partial negative charge because of the electronegativity difference. Okay, and the cyanide ion will attack on this carbon. Okay, and you know that from earlier class, first step is a slow and reversible step. Okay, slow and reversible step. Now here the planar carbonyl compound will undergo structural changes. Okay, and hybridization of the carbon also changes. Okay, like this. C cyanide O minus, and the bonds will be as this. Okay, and now there will be attack of the Na plus ion or hydrogen ion. We may take any one. Okay, for example, if you take H plus ion is going to attack, then you will get CnOH, the bonds as it is. Now this compound is called as cyanohydrin. This is called as cyanohydrin. So when the carbonyl compounds are treated with the hydrogen cyanide, okay, we get cyanohydrins. Here hydrogen cyanide is a covalent and it is less nucleophilic in nature. Okay, the NaCl is the ionic one, so it is donating the nucleophile readily. Okay, here we need to consider that the addition of HCl to carbonyl compounds is catalyzed by alkali. What it means? Whenever you take the HCl, add to the carbonyl compound, the reaction will be taking place very slowly because HCN is covalent, is a covalent and less nucleophilic, okay, and it does not release the cyanide ions readily, okay. It does not produce nucleophile, does not produce nucleophile. What is the nucleophile in this case? Cyanide ion, nucleophile readily. That is why what we are going to do, we are treating this HCN with NaOH so that we will get NaCN. Here NaCN is ionic, readily produce nucleophile, okay, Cn minus, okay. This you need to remember, okay. So this is all about the addition of hydrogen cyanide to the carbonyl compounds gives the class of compounds called cyanohydrin. Means there will be a cyanide group and OH group here, okay. Yes, we shall consider the addition of sodium hydrogen sulfide, okay. The second reaction is addition of sodium hydrogen sulfide. Carefully look at this spelling, sulfide, ITE, okay. Its formula is NaHSO3. The second type of the nucleophilic addition is addition of sodium hydrogen sulfide, okay. Yes, this NaHSO3 is also called as sodium bisulfide. Okay. Let us see what happens here. Take the carbonyl compound, add the NaHSO3. Add the NaHSO3, and you know that first step is a slow step and the reversible step. Now what happens? This is O minus, no? Delta minus, this is delta plus. And in this case, this is plus, this part is minus. Okay. Yes, now what happens? This O will be attacked by the Na, this SO3H group will attack the carbonyl carbon. Okay. Now we will get SO3H, then ONA. And it undergoes proton transfer. It undergoes proton transfer. Proton transfer occurs. So now this H will go toward this, Na will come towards this. So now the structure is like this. Hydrogen group is present on the carbon. Okay. Now it is a salt. It is a salt, also called as adduct. Adduct means addition product. Adduct means addition product. It is also an adduct. Okay. Now, what is the importance of adding NaHSO3, that is sodium bisulfide, to the carbonyl compound? The importance is that the aldehydes are generally purified by treating the compound with NaHSO3. And here, the very important point is that the addition of NaHSO3 and its equilibrium will be on right hand side for the aldehydes. Means aldehydes readily undergo this reaction. Okay. Equilibrium. The important note is that equilibrium lies on right hand side. What is our right hand side? The product. Okay. Product for aldehydes. It means what? The aldehydes are readily reacting with the NaHSO3 to give this salt. Okay. What about the ketones? Ketones equilibrium lies on LHS, that is reactant cell. Reactant cell for ketones. For ketones. It means what? Equilibrium is on LHS means it is not going to proceed. That is what we have discussed. Ketones are not readily undergoing the nucleophilic addition reactions. Okay. And the importance of this is using NaHSO3 we can purify the aldehydes. Okay. And when this compound is again treated with a small amount of alkali or acid, it gives back the original reactant. It gives back the original productant, original reactant. Okay. So it is this method is used to purify. This method is used to purify aldehydes. This is very important in chemical synthesis. Whenever you prepare the aldehydes, it will be purified by using the NaHSO3. Okay. When aldehyde is treated with NaHSO3, you will get a salt. When that salt is again treated with alkali or little amount of acid, it gives back the original aldehyde in the pure state. Now let us discuss about the addition of Grignard reagent to the carbonyl compounds. It is already discussed in the chapter called alcohols. Okay. Let us discuss once again. Take the carbonyl compound. Okay. Take the carbonyl compound. It may be an aldehyde or ketone. Okay. Take the carbonyl compound. To this add Grignard reagent. Say you know that the oxygen is most electronegative, it will pull the 5 electrons and becomes electron rich. So delta minus. And the carbon is losing the electrons, so therefore it gets a delta plus, partial positive charge. And here in the Grignard reagent, okay, this is delta minus, alkyl part is delta minus, and the magnesium metal is a positive one. Okay. Yes. Whenever these two are treated, okay, the negative part gets attached to the carbonyl carbon. The negative part gets attached to the carbonyl carbon. Always in the nucleophilic addition reactions, the nucleophile will attack first. That's why it is called. Okay. Now it will become MgX will attack on this O minus. Okay. Now it will be OMgX. Okay. When this adduct, what is this called? Adduct means the product obtained after addition is called as the adduct. Okay. It is the intermediate. Okay. When it is hydrolyzed means when H2O is added to this, this H2O will add like this. Here H plus ion will add, here OH minus will add like this. So what you are getting OH, that is alcohol. You are getting the alcohols. Whether it is a primary alcohol, secondary alcohol or tertiary alcohol, that depends on what carbonyl compound you are going to take and what is this R. Okay. Yes. Here, for more example, you have to refer to the alcohols chapter. There you will get the conversion of the carbonyl compounds to the primary alcohols, secondary alcohols and tertiary alcohols. Okay. Yes. Let's go for the fourth type of nucleophilic addition reaction. That is addition of alcohol. To the carbonyl compound. When alcohol is added to the aldehyde, you will get acetols. Okay. When this alcohol is added to the ketones, we will get the ketones. Let us see that. Okay. The addition of alcohols to the aldehydes. To aldehydes. Okay. Gives ketones. And this also, the aldehydes generally react with monohydric alcohols. One aldehyde will react with the two monohydric alcohols. Two monohydric alcohols. Let's see that. Okay. Take RCHO. This is an aldehyde. And take a monohydric alcohol. For example, R-OH. What is this? Monohydric alcohol. Monohydric alcohol. Monohydric alcohol means the alcohol with one OH. Okay. The reaction between these two takes place in the presence of dry HCl. In the presence of dry HCl. Dry HCl means the pure HCl without water content. Okay. Now, what happens here? There is a positive part and there is a negative part. Okay. For example, you have the positive part like this, delta plus and delta minus. Okay. Here the carbon will be attacked by the OH minus. Will be attacked by the OH minus. Okay. Now you will get RCH, and here on this C you are getting OH, and this O will join with this plus. Okay. So this OH. See, it appears to be alkyl plus oxygen is called as alkoxy. Alkoxy, and this compound is called as alcohol. So this is alkoxy alcohol. This is alkoxy alcohol. Alkoxy alcohol is called as hemiacetal. Is called as hemiacetal. Is called as hemiacetal. And further, this compound reacts with one more monohydric alcohol. One more monohydric alcohol. Let's take R double dash OH. R double dash OH. Here we have R dash. Now take R double dash. To distinguish this, we are going to take that. Okay. Now what happens? This hydrogen will be replaced with the R double dash. And this H plus ion will combine with the OH minus ion to give the water. Byproduct is water. Okay, now let's see that R CH. Here we have OR dash, and this is OR double dash. What it appears? This is one alkoxy group, this is another alkoxy group, and remaining will be CC single bond, and it is a alkane, or we can call it as hydrocarbon. See, this is called the acetal. Okay. This is called as acetal. What is acetal? Dialkoxy hydrocarbon. Dialkoxy, or it is also called as geminal. When two groups are present on the single carbon atoms, it is geminal. When present on the adjacent carbon atoms, then it would be called as vicinal. Okay, you know about that. Okay, it is a gem. Gem means geminal. Geminal dialkoxy. Geminal dialkoxy hydrocarbon, or you may call that as a alkane. Okay. Now, when aldehydes are treated with the monohydric alcohols in the presence of dry HCl, you will get alkoxy alcohol. This is called as hemiacetal. This further reacts with the monohydric alcohol to give acetal. Okay. And here, when this compound, that is acetal, is treated with the dilute acid, original compound, gives back the original compound. For example, I will show it by H plus. Means in the reverse order, when this compound is treated with H plus and gives back this, and this gives back original products. Okay. Let us discuss about the addition of dihydric alcohols to ketones. Okay. Ketones generally react with the dihydric alcohols. Okay. RC double bond O R dash. It is a ketone. When this is treated with a glycol, ethylene glycol, let us take ethylene glycol. Ethylene glycol. Okay. It is called ethylene glycol. Now, what happens? This reaction also takes place in the presence of dry HCl. It is also a reversible process. Okay. Here, this H plus ion from this, H plus ion from this will combine with O to give H2O. To give H2O. H2O will be released. H2O will be released from this. Now, it is like the condensation reaction. Condensation means there will be removal of something from the reactants. Okay. Now, what we can get? RC R dash. This one bond connect with O, CH2, and another one connect with one more O, CH2. So this is called a ketol. Here ketol is a cyclic product. Here ketol is a cyclic product. Okay. Here I have not shown you the bond between the carbon and oxygen. Here I am going to show you. That's it. Okay. This is a ketol. When these acetols and ketols are treated with dilute acid, gives back the original reactant. Okay, original reactant. That I can write here. Note: the acetols and ketols, when treated with dilute acid, gives back aldehydes and ketones respectively. When the aldehydes and ketones are treated with alcohols, you will get acetal and ketones. When these products are treated with the dilute acids, gives back the original reactants. Okay. So this is all about the nucleophilic addition reaction. We have one more nucleophilic addition reaction, that is the addition of ammonia. Now we shall discuss about addition of ammonia and ammonia derivatives to the carbonyl compounds. I am going to write the general reaction equation. Okay. From that we can easily predict the other reactions. Okay. Observe carefully. Take the carbonyl compound. This is a carbonyl compound. Okay, and I am going to take NH2Z, where Z may be hydrogen or any other groups. Okay, when Z is equal to hydrogen, that is ammonia. When Z is other groups, there will be other reagent. Okay, so this is what I am calling it as reagent. Okay. Then this will react, nucleophilic addition will take place here. Okay, and you know that this is delta minus, this is delta plus, and here the H plus ion will be there, remaining will be the nucleophile part. H plus ion will attack on this oxygen. Okay, the H plus ion will attack on the oxygen. Okay, now you will get COH, and the remaining part is what? NH single Z. NH. This is called anode, and it is the intermediate, Okay, when this undergo rapid dehydration, from this OH minus will be coming, it take the H plus ion, so overall it is H2O, and during elimination reaction there will be formation of one more bond between the carbon and the nitrogen. So you will get C double bond NJ. Okay. Here, what is the product is dependent on the what reagent we have taken. Okay. Now we shall see some examples by taking Z. Okay. Here Z may be equal to hydrogen, or it may be alkyl or aryl group, it may be hydroxyl group, or it may be the NH2 group, it may be phenyl hydrazine, okay, 2,4 DNP, that is it will be phenyl hydrazine, the Z may be phenyl hydrazine, it may be the 2,4 DNPH, it may be semi-carbazide, okay, like that. Let's see that, okay, by taking, okay, if the reagent where Z is hydrogen, if Z is hydrogen, what will be the reagent? Reagent name when Z is equal to H is NH3, that is ammonia. Okay. Then what will be the product? Okay. What will be the product? That is C double bond NH. Okay, C double bond NH. What is the product name? It will be a imine. When the carbonyl compound is treated with the ammonia, the product obtained will be imine. Okay. When Z is equal to alkyl or aryl group, then the reagent will be called as amine. Look at the difference. Ammonia where 2 M are there, and in amine only 1 M is there. This you have to note. Okay. Then the product will be C double bond NR. Okay. Here the product name is substituted imine. So double bond NH is imine now. Here where hydrogen is replaced with R. So therefore it is called as substituted imine. This is also called as Skipp's base. You need to remember this. What is Skipp's base? It is a substituted imine. When you get this, when the carbonyl compound is treated with the amine, you will get the substituted imine called as Skipp's base. Okay. When the Z is OH group. What is the reagent? NH2OH will be called as hydroxylamine. Will be called as hydroxylamine. Okay. Now the obtained product will be like this. Where Z is what? OH, no? So you can write it. Double bond NOH. Where hydroxylamine, when treated with carbonyl compound, gives the oxide. What is the compound name? Oxide. It will give you the oxide. Here, this may be any group. Okay, R dash may be any alkyl or aryl or something. Okay, or you are going to treat the carbonyl compound. Either it may be aldehyde or ketone. Okay, and let's take when Z is NH2 group. When Z is NH2 group. So overall the formula will be NH2. It is called as hydrazine. It is called as hydrazine. Okay. Then the product will be C double bond N NH2. Okay. What is the product name? It is called as hydrazone. The product is called as hydrazone. Okay, hydrazine will be converted as hydrazone. Okay. When Z is phenylhydrazine. Similarly, what will be the product? Phenylhydrazone. This hydrazine will become hydrazone. Okay. What is that phenylhydrazine? This is this formula NHC6H5. In the place of C6H5, you may take the benzene ring also. Okay. Now NH2 NHC6H5 is called as phenylhydrazine. Phenylhydrazine. Now, what will be the product? C double bond N NHC6H5. This is called as the class of the compound called as phenylhydrazone. Phenylhydrazone. Okay. If Z is 2,4 DNP, what is that? NH benzene ring 2. This is the position 1. This is the position 1. This is the position 2. You may take this as 2. This is position 4. 1, 2, 3, 4. No? So 2,4 phenylhydrazine. What will be the reagent name? 2,4 dinitrohydrazine. What is the reagent name? 2,4 dinitrohydrazine. So now what will be the product? C double bond N. Okay. Now we have NH benzene ring. Under the second there is a NO2 group and here also NO2 group. What is the product called? 2,4 dinitrophenylhydrazone. The product will be 2,4 dinitrophenylhydrazone. Okay. Yes, we have one more reagent. Okay, that is semicarbazide. Let us take that. Semicarbazide. When Z is NHCONH2, the reagent name will be called as semicarbazide. This azide. Okay, the product will be C double bond N. Just replace that Z with this. Okay, NH, NH2. This is called as semi-carbazone. The product is called as semi-carbazone. Yes, we have up to here about the nucleophilic addition reactions in the NCERT book. Other than these reactions, we have variety of examples in private author books. Okay, let us recall the nucleophilic addition reaction. See the carbonyl compound where the carbon is electron deficient, that is why it will be attacked by the nucleophile in the first step, therefore it is a nucleophilic addition reaction. Here we have discussed about the addition of hydrogen cyanide, addition of sodium hydrogen sulfide, addition of Grignard reagent, addition of alcohols, addition of ammonia and its derivatives. Okay, when Z is H, it is an ammonia, the product will be imine. Okay, like that we have seen variety of ammonia derivatives will give variety of products. Okay, practice a lot on this in the CET and theory examinations. It is very, very important. Now we shall discuss about the reduction of carbonyl compounds. We know that the partial reduction of these carbonyl compounds will give the corresponding alcohols. The complete reduction of the aldehydes or ketones will give the hydrocarbons. Here we have two types. One is partial reduction and the other one is complete reduction. Let us go through that. Okay. First one is partial reduction. Partial reduction of these carbonyl compounds. Let us take the carbonyl compound C double bond O. What is this? Carbonyl compound. It may be an aldehyde or ketone. Okay. When this carbonyl compound is partially reduced, we may use a catalytic hydrogenation for this. What is catalytic hydrogenation? Addition of hydrogen in the presence of a catalyst. Okay. Catalytic hydrogenation of carbonyl compound will give the corresponding alcohol. Will give the corresponding alcohol like this. Okay. What is this? Alcohol. This method is called as catalytic. We are using a catalyst now, therefore catalytic. Addition of hydrogen is called as hydrogenation. It is a catalytic hydrogenation. Okay. If you take the formaldehyde, you will get the methyl alcohol. Methyl alcohol. That is primary. If you take the acetaldehyde, you will get the ethanol. Like that. Okay. Yes. If you take the acetone, you will get a propan-2-OL. Here the type of alcohol, it may be primary, secondary or tertiary, is dependent on the type of carbonyl compound you are going to take. This is all discussed in the alcohols chapter. Okay. Yes. Now let us see some reducing agents. Okay. When carbonyl compound is treated with either sodium borohydride or the lithium aluminum hydride. Okay. Those are called as reducing agents. Sodium borohydride. What you get? You will get the alcohol. You will get the alcohol. Okay. Isn't it? This is called as partial reduction of the carbonyl compounds to alcohol. Let us consider some complete reduction. Okay, let's go for complete reduction. See, these are all general reaction equations. You need to have some specific examples that you have to practice. Here you may take R, here it may be R dash, okay. R may be R and R dash may be equal to hydrogen, aryl group or alkyl group, okay. Yes. Let us go for complete reaction. Here we have some named reactions. The first one is Clemmensen reaction. Clemmensen reaction. Clemmensen is a scientist. He treats the carbonyl compound. He treats the carbonyl compound. He treats the carbonyl compound with zinc amalgam. With zinc amalgam in the presence of HCl. What is this ZnHg? It is nothing but zinc amalgam. Amalgam means combination of mercury with some other elements. Okay. Now it is called as zinc amalgam. Okay. When the carbonyl compound is treated with the zinc amalgam in the presence of hydrochloric acid, you will get a hydrocarbon. You will get a hydrocarbon plus H2 plus H2. Okay. For example, you take acetaldehyde, that is CH3CHO. What is this? An aldehyde. When acetaldehyde is treated with zinc amalgam in the presence of hydrochloric acid, you will get a corresponding hydrocarbon, that is ethane. That is ethane plus H2. That oxygen is coming out. Removal of oxygen is called as reduction. So now, what is Clemmensen reduction? The complete reduction of the carbonyl compound into hydrocarbon using zinc amalgam in the presence of HCl. Okay. We have other method now. Let us consider the other complete reduction method. That is called as Wolff-Kishner reduction. That is Wolff-Kishner reduction. Yes. Here we are going to treat the carbonyl compound. It may be an aldehyde or a ketone. When this is treated with the hydrazine, so you know that it is a reversible step. Okay, this is what ammonia derivative. You will get C double bond N NH2 with the release of H2O. In the previous case, we have studied this. Okay, it is a nucleophilic addition reaction up to here. When this further treated with KOH, that is potassium hydroxide, in the presence of high boiling liquid, that is glycol, and on heating, you will get a hydrocarbon. With the release of nitrogen gas. See, you need to consider the similarity between this Clemmensen and Wolff-Kishner reduction. Both these are complete reduction of carbonyl compounds into hydrocarbons. The byproduct here is water and here is nitrogen gas. Okay. Now, take the particular example. Take the acetone, CH3COCH3. What is this? This is acetone. When this is treated with hydrazine in the first step, instead of writing so much reaction equation, I will condense it to a simple step. When acetone is treated with the hydrazine in the first step, and in the second step you need to treat this intermediate with KOH in the presence of glycol. So you will get a corresponding hydrocarbon. What is the corresponding hydrocarbon? CH3, CH2, CH3. CH3, CH2, CH3. Okay. So this is what? Propane. Okay. Plus N2 gas. And here you have seen that H2O also came out as byproduct. Okay. Instead of writing this much, you can condense this to this. And here I am showing you the byproducts. Okay. So this is all about the complete reduction of the carbonyl compounds to hydrocarbons.